Good day. I welcome you all at the current lecture on the numerical problem solving of a 3-inch arch of the subject Structural Analysis 1 and the related subject code is CEPC 503 and module number is 2. Myself Sandeepan Shah, Assistant Professor for the Department of Civil Engineering of Greater Kolkata College of Engineering and Management under JIS Group. Let us first have a look on the topics that we are going to learn in this lecture. In this lecture, we will solve another problem on 3-inch arch. Let's do another problem on 3-inch arch, that is this one, as shown in the figure. So as per the problem, we have a central rise of 8 meter along with a span of the 3-inch arch is 40 meter. The 3 inches are situated at A, C and B. In case of the loading, the 3-inch arch carries a uniformly distributed load, that is here, of 20 kN per meter over the left half of the span, that is from here to here, that is the left part of the span, along with a concentrated load of 100 kN, which is acting at the right quarter span point, that is here. So in this problem, we have to find out the reaction at the supports. That means we have to calculate VA and VB along with the normal thrust and shear at a section 10 meter from the left support, that is somewhere between here. So we have to take a section where all the necessary calculations are to be done, and this section situated at a 10 meter distance from the left support. So somewhere between here. So the distance is 10 meter from the left support. Now let us solve the problem. One thing to keep in the mind, that this particular arch is a circular arch. So let us first solve the problem, and in order to do so, we have to calculate the vertical reaction VA and VB, that is this is VA and this is VB first. So to calculate VA and VB, taking moment about P, we have total summation of moment about P equals to 0, as this B is a hinge support. So we have VA into 40 minus 20 into 20 into 30 minus 100 into 10. We are considering the moment caused by the vertical support at A as positive, because we are taking the clockwise moment as positive and the anti-clockwise moment as negative. So this particular moment is is in the clockwise direction and this moment is in the anti-clockwise direction, followed by this moment. So these two moments, that is this and this, are negative, this one is positive. So total equals to 0. That is the total summation of the moments are is 0. So calculating, we have VA equals to 325 kilonewton. From this we can get VB, which is equals to 175 kilonewton, as VA plus VB equals to 20 into 20 plus 100, and from this we get the value of VB as we have already calculated VA. So from the calculation we get the VA as 325 kilonewton and VB as 175 kilonewton. Now let us calculate the horizontal thrust, that is H. So in order to calculate, we have to take the moment about point C and summation of moment about point C equals to 0, as C is at the C point there is a hinge, that is here, and from this point up to this point the distance is 10 meter. So taking moment about C on the right hand side, so we have VB into 20 minus H into H and 100 into 10. Again I am reminding that we are taking the forces on the right hand side, that is at the this side of the arch, that is the right hand side of the arch. So the summation of all the moments here equals to 0, and we have already calculated VB, that is 175 kilonewton. So putting the value of 175 at VB, we get H equals to as 312.5 kilonewton. So we have H equals to 31215 kilonewton. Now, as per the next part of the calculation, we have to calculate the normal thrust and shear at a section 10 meter from the left support, that is at this point. Suppose this point, the name of the point is D. So the point D is situated at a 10 meter distance from the left hand support, that is from A. So we have to calculate the normal thrust, that is this one, and shear at this point, that is at point D. To calculate the normal thrust and shear at point D, we need to understand the properties of circle, as we are dealing with a 3-hinge circular arch. So first let us draw the detailed geometry of the circular arch. So here we have the arch where The hinge points are here. That is one point, one hinge is here, one hinge at the crown, and one hinge here. That is at A, C, and B. And we are given the span of the arch as 40 meter, which is L, and we have the central height, that is 8 meter, which is equals to H. Now we have to calculate the normal thrust and shear at point D, that is here. So as this is this circular arch is a circle, is a part of a circle. So this circle have a has a center. So let us look at the center of the circle. If we draw the radius, let us assume that the center of the circle will be lying somewhere here, and the center is O. Now let us connect OD. The angle between OD and OC, that is theta. Then draw a perpendicular from point D on the line OC. So we have point P. So we are getting a rectangle from this geometry, that is OPT. O means this point, P means this point, and D means this point. And these 3 points together form this triangle OPD. And from the properties of circle we have, H into 2R minus H into, sorry, this is equals to L by 2 into L by 2, where R is the radius of the circle, which is OC, that is OC is the radius of the circle. C means this point and O means this point. That is the center of the circle. So we have H equals to 8 meter, that is here, and L equals to 40 meter, that is here. So putting the value of L and small h, we get capital R, that is the radius of the circle is 29 meter. So now as per the properties of triangle OPD, we have theta. So theta equals to, that is the this angle, and we can also take theta as the slope at D, that is here slope at D. So slope at D theta equals to, so slope at D, that is theta, equals to sine inverse 10 by R. 10 means dp, dp equals to 10 meter. That is, D is this point and P is this point. So we have 20.17 degree. So the slope at D, so the slope at D is 20.17 degree. We did this calculation, that is to calculate the slope at D. We have applied the simple trigonometrical concept of rectangle OPD, that is this. So from the simple trigonometrical concept of triangle OPD, we have the calculation, that is slope at D, which is theta equals to 20.17 degree. Let me remind of one point, that is the dp equals 10 meter. So how did we get dp equals 10 meter? As you can see that from A to D we have 10 meter, and from A to this point we have 20 meter, as this is the central point of the arch. So geometrically this distance is 10 meter. So this is dp. The same thing applies here. This is dp, that is 10 meter. So by this calculation we get the value of dp equals to 10 meter, and we put the value of dp at here, and then we calculate the slope at D, that is theta, and we get theta equals to 20.17 degree. Let me give the detailed calculation of this. So how do we get this? So as per the trigonometrical concept of triangle OPD, we get, that is from triangle OPD, this is P, this point is P. So we have dp by OD equals to sine theta, and from this theta equals to sine
inverse dp by od. So then we put the value of dp and we get this calculation. So we have 20.17 degree. As we have already mentioned that dp equals to 10 meter and od is the r, that is 29 meter.
So we have calculated the value of theta. Now, in order to calculate the normal thrust, and shear at point D, first we need to calculate the vertical shear at D. So vertical shear at D is V equals to VA minus 20 into 10. So the summation of all the vertical forces up to point D is this one. So VA we have 325 minus 200 and we have 125 kilonewton. So putting the value of P to calculate the normal thrust, we have normal thrust N equals to V sine theta plus H cos theta, and we get this from the property of 3-hinge arch. There is a property of 3-hinge arch, and we have already get the value of H from the calculation that H equals to 312.5 kilonewton, and we have V equals to 125. This is V. So putting the value of V and H in this calculation, we have so 125 sine 20.17 degree plus H equals to 312.5 into cos 20.17 degree, we get the normal thrust equals to 336.437 kilonewton, and we have the shear, that is Q equals to V cos theta minus H sin theta. Then again putting the value of V and H, we get 125 cos 20.17 degree minus 312.5 sine 20.17 degree. We get Q equals to 9.575 kilo Newton. So As per our calculation, we get normal thrust, that is N equals to 336.437 kilonewton, and the shear Q equals to 9.575 kilonewton. Thank you.